Hello, my name is Nathan Antonio, and I'll be going over the differential equation that models glucose absorption in IV therapy using the method of the Laplace transform. This differential equation is displayed as such. dy over dt equals r minus ky. And around this equation, I have labeled which each component of the differential equation represents. Rewriting this equation as y prime plus ky equals r, we can clearly see that it is a linear first-order non-homogeneous IVP differential equation where y of 0 is equal to y naught. So as I had mentioned, we are using the method of the Laplace transform to solve this differential equation. And to start, we need to know what the Laplace of a function of y of t is and its their derivatives. And right over here to the right of the page, you can see that we have established that y prime and y double prime and its Laplace is right over here. So this leaves us with what we have to do next. So to do next in this specific differential equation, we must take the Laplace of both sides. So once we take the Laplace of both sides of the equation, it leaves us with the Laplace transform of y prime plus k times the Laplace transform of y equals the Laplace of r. So we just did the right side and we just did the left side. So we know what the Laplace transform of y prime is, and we know what the Laplace transform of y is from what we have established earlier. So plugging in our transforms, we are left with s times y of s minus y of 0, which we know y of 0 is equal to y naught. So we can just change this to y naught in the future term, plus k times y of s equals r over s. Next, we can factor out a y of s, and we are left with the equation y of s times s plus k minus y naught. As I had mentioned, I had swapped these two because y of 0 is equal to y naught equals r over s. Next, what we can do is we can add y naught to both sides, and then we can divide by s plus k to isolate this y of s term. We are then left with y of s equals r over s times s plus k plus y naught over s plus k. So from here, we are now in a function of s, but we want our equation is a function of time. So now what we must do is take the inverse Laplace transform of what we have solved for, which we are left with y of t equals the inverse Laplace transform of r over s times s plus k plus y naught over s plus k. And from here, we can use the linearity for the inverse Laplace transforms and then partial fraction decomposition for r over s plus k. Oh, sorry, r over s times s plus k. My apologies. From this, we are yielded with a over s plus b over s plus k equals r over s times s plus k. Now we're going to multiply this whole thing by s times s plus k. Now we can't forget about this right here. We're also going to add y naught times the inverse Laplace transform of 1 over s plus k. And thanks to our lovely Laplace transform tables, we already know what this is. We'll solve for it at a later time. We're just going to deal with this partial fraction first. So by multiplying by this common denominator, s times s plus k, we are left with this simplified version of this equation, as plus ak plus bs equals r. Now, by solving for a, we can see that a equals r over k. We know this because r can only be equal to a times k. And by solving for a, we get a equals r over k. And that's great because as plus bs must equal 0. We don't have an s term on the right side of the equation. So there is only one thing that this could be, the negative version of a. So as plus bs must equal 0, like I had mentioned. So b must equal negative r over k to satisfy that equation. Now, all we have to do is simply plug in our a and b values back into our partial fraction, and then take the inverse Laplace transform all the way through, which I have done right here on this step. All we have to do is factor out r over k and then a negative r over k respectively, and we are left with r over k times the inverse Laplace transform of 1 over s plus negative r over k times the inverse Laplace transform of 1 over s plus k plus y naught times the inverse Laplace transform of 1 over s plus k. We are then left with this right here, r over k minus r over k e to the negative kt plus y naught e to the negative kt. And simplifying this equation y of t, we are left with r over k plus y naught minus r over k times e to the negative kt. All I did was factor out e to the negative kt, move this to this side so I can not have this ugly negative right here and have this y not in front. And there you have it. Thank you.